Guys, welcome to PM Networking. Today we are going to discuss real-time scenario, right? In real time, how you will configure BGP. So today you will understand where we need to configure indirect BGP neighborship. Either I am talking about IBGP, indirect IBGP neighborship, or indirect ebgp neighborship, right? So my scenario is this, right? This is my topology, and this is provider network, service provider network. This is service provider network, and this is my customer network. This is my site 1 and this is my site 2, right? Or you can say this is my customer 1 and this is my customer 2. So for connectivity between site 1 and site 2, we will take connectivity from service provider. Guys, I am not talking about internet service provider. There is huge difference between ISP and SP. ISP is internet service provider and SP is service provider, right? Internet service provider means the provider who will provide you internet, right? And SP means service provider, means the company who is providing connectivity between two sides, right? Between two LAN network, right? So suppose this is my LAN 1 and this is my LAN 2. So we need connectivity between these two LAN, right? So I will take connectivity from service provider, right? So this is network of service provider. This is my customer network and this is my customer network, right? So this is PE router. This is PE router. PE means provider edge router, and this is my another PE router, right? Another side PE router, provider edge router, right? And this is general router, P router, normal configuration router. So if I will configure BGP on this router, then we don't need to configure indirect neighborship between P1 and P2, right? But to configure BGP on this router, we need to purchase high configuration router, right? Router with good CPU utilization, router with good memory, right? Then cost will be definitely increased. So I will use normal router over here, and I will use two good configuration router, right? That is PE1 and PE2, provider edge router 1, provider edge router 2. After that, this is my CE router. CE means customer edge router, and this is my customer edge router, right? Guys, I am going to discuss how you will configure BGP in real environment, how company is configuring BGP, how company is using BGP protocol in their network, right? So you will understand each and everything step by step, but please make sure you will watch this video till the end, right? You will learn many things, right, in this video. So guys, which type of neighborship we have to form between PE1 and PE2? PE2 PE, we will form IBGP neighbor, because this is ISP network, this is SP network, service provider network, and the same service provider network router, these P1 and P2 is router of same service provider. So service provider will use same AS number on this router. So I am going to configure BGP 100 over here on R1 and on R3. So here we will configure indirect IBGP neighbor, right? And between CE and PE, right? Between PE to CE, we will configure ebgp. Because this is my customer network, I will use definitely different AS number. Suppose I am using AS200 over here, and here we are running AS100. So which type of neighborship will form between PE to CE? ebgp, right? ebgp. Okay. So after that, for connectivity between R1 and R3, company will use IGP protocol or static routing. You can use static routing as well, but it's very difficult to configure static routing, right? So we will use IBGP router. And if I talk about companies, right? So many service provider company, most of the service provider companies using OSPF, right? And ISIS routing protocol. If the service provider network is very large, then they will use ISIS routing protocol. If service provider network will be small, then they will use OSPF. And guys, there will be multiple router here, right? Like this router will also connect through this router, right? Like this, right? So we will use loopback to form ebgp neighborship between P1 and P2, right? Loopback. So I will create one loopback over here, 1.1.1, and here 3.3.3.3. With the help of this loopback, we will form ebgp neighborship between PE1 and PE2. After that, I will configure BGP 200 over here, and we will form ebgp neighborship, right? ebgp neighborship, right? And let's see how to configure. Let's start. Actually, I am going to configure IP address 12.1 over here, right? On R1 serial 2/0. As you can see over here, I had already configured IP address on the router, right? Let me show you. So IP interface brief exclude unassign. You can see, right? On every router, I had already configured IP. So IP interface brief exclude unassign, right? Go to R3. So IP interface brief exclude unassign. You can see there is one loopback 3.3.3, right? Now in the same way, I had configured IP on R4. Let me show you. So IP interface brief exclude unassign, right? Go to R5. Let me show you the IP address. IP interface brief exclude unassign. You can see, right? So guys, now I am going to configure BGP on router 1 first, right? So go to configure terminal mode, router BGP, neighbor is 3.3.3.3, and whose remote AS is 100. Fine. Let me configure the same thing on R3. Router BGP 100 and neighbor is 1.1.1.1 and remote AS is 100. Fine. So IP BGP summary, but you can see neighbor is down, right? My neighbor is down. Why? We need to update source IP, right? Source IP, because actually now R1, when R1 will send open message, right? What will be the source IP? Source IP will be 12.1, right? And destination IP will be 3.3.3. So we have to modify source IP, right? Let me modify on R1 as well as on R2. Go to R1. Okay, so neighbor 3.3.3.3 and update source loopback 1. Fine. Let me configure same thing on R3. Router BGP 100 neighbor 1.1.1.1 1.1.1.1 and update source loopback 1. Fine. Now let me show you the BGP table, BGP neighbor table. So IP BGP summary. Now neighbor is still down. So why neighbor is down? Because connectivity between R1 and R3 is right. In R1 routing table there is no route for 3 network 3.3.3.3, right? So we need to configure OSPF between R1, R2, R3, right? Among R1, R2, R3. So let me configure OSPF first. Router OSPF process ID 100. After that network 1.1.1.1. Let me configure OSPF by interface loopback 1 IP OSPF 100 and area 0. Okay, interface serial 2/0 IP OSPF 100 and area 0. Go to R2, exit. So IP interface brief. You can see there is 2 IP address, right? On serial 0/0 and serial 2/0 and 2/1, right? Let me configure OSPF router OSPF 100 and network 0.0. Let me put 0.0.0 because I want to enable OSPF on all the interface, right? So area 0. Exit, go to R3, router OSPF 100 and exit interface serial 2/0, IP OSPF 100 and area 0, right? Exit interface loopback 1, IP OSPF 100 and area 0. Okay, so now you can see there is connectivity. So IP root, so there is one network, yes, right? Now let me show you the BGP table. So IP BGP summary. Now you can see neighbor is up, right? So which type of neighborship is formed between R1 and R3, between P1 router to P3 router to P2 router, sorry, to P2 router? IBGP, right? Indirect IBGP neighborship, right? Now we need to configure customer edge router, right? So go to customer edge router and configure BGP over here. So router BGP, and I am using AS200 over here. So 200. After that neighbor is 14.1.1.1 and remote AS is 100. Fine. Let me configure same command on R5. Router BGP 200 and neighbor is, let me check the IP address, 35.1.1.3 and remote AS is 100. Fine. Let me show you the BGP table, BGP neighbor table. So IP BGP summary, right? So neighbor is down, right? So go to R1. After that router BGP 100 and neighbor is 14.1.1.2, right? 14.1.1.2 and remote AS is 200, right? Let me configure same thing on R3. Configure terminal, router BGP 100 and neighbor is 35.1.1.5, 31.1.1.5 and remote AS is 200, right? Let me show you the neighbor table. So IP BGP summary. So you can see over here there is two neighbor, both are up, right? Now check on R5, same command, right? Now neighbor is up. Now what we need to do over here is, now we need to advertise this prefix, TAN prefix in BGP, so that this router will share the BGP prefix with R1, right? Now let me configure CE1 router, customer edge 1 router and router BGP 200. After that network is 10.1.1.0 and mask is 255.255.255.0. enter. So IP BGP, right? So there is prefix and this is best and valid, so this router will install in routing table as well. So IP root, right? And this router will share this prefix with PE router R1, right? Let me show you the BGP table of R1. So IP BGP, you can see there is prefix 10.1.1.0 and this prefix is best and valid, so this router will install this prefix in their routing table as well. So IP root, right? So yes, there is one prefix. Okay, now let me show you the BGP table of R3. So IP BGP, guys, there is 10 prefix, yes, but this is not a best route, right? Not best, because next hop IP address is 14.1.1.2 and 14.1.1.0 is not reachable from R3, right? So whenever this router will share prefix with ibgp router, they will not modify source IP, right? So let me run the one command over here, router BGP 100 and neighbor is 3.3.3.3, right? And next hop self, right? This command we have discussed about these things in previous video, right? Let me enter. Now this router will modify next hop address, right? When this router will install this prefix, now you can see still not clear IP BGP star soft in, right? And now you can see this is best route, right? This is a best and valid. So this router will install this prefix in their routing table as well. So IP route, so yes, there is prefix. In the same way, I have to advertise this prefix in BGP. So go on this router, right? After that, configure terminal router BGP 200 and network is 20.1.1.0, mask is 255.255.255.0. now this router will receive this prefix, so IP BGP, right? So there is one network and this is valid and best. So this router will share this prefix with R1, but R1 will not install in their routing table, right? Let me show you. So IP BGP, so yes, R1 will not install this prefix in their routing table because this is not a best route, right? So what we need to do over here is we need to configure next hop self rule over here as well, right? So router BGP 100 and neighbor is 1.1.1.1 and next hop include next hop self, right? Now let me show you the BGP table of R1. Clear IP BGP star soft in. Okay, now this is best, right? Guys, will this router will ping 20.1 from here? Let me show you. Ping 20.1.1.1 and source will be 10.1.1.1. will it ping? No, right? Because understand guys, here when I will ping, what will be the source IP? 10.1 and destination IP will be 20.1, right? When this router will check their routing table to forward traffic in 20 network, right? After that this router will get to know exit interface, so IP route, right? So 420, there is no route for 20 network, right? As you can see over here, there is no route for 20 network, and there is on R5 there is no route for 10 network. So IP route, there is no route for 10 network. Why? Remember ebgp rule. When this router will share this prefix 20.1.1.0 to R3, right? This router will include their AS number. What will be the AS number? 200, right? When the R3 will share this prefix to R1 20.1.1.0, AS number 200 and 100, right? When this router will share with ebgp router, when this router will receive this prefix, it will see their own AS number, right, in the update. So this router will not accept that update, right? Remember the rule in ebgp, loop avoidance rule, right? So let me run one more command over here, right? Let me run one more command over here. Router BGP 200 and neighbor is 14.1.1.1, allow AS in, right? Now this router will install 20 prefix in their routing table, so IP BGP. So yes, there is route for 20 network and this is best and valid, so this router will install in their routing table as well, right? In the same way, let me allow to R5 to accept prefix where AS number is 200, right? So router BGP 200 and neighbor is 35.1.1.3, 35.1.1.3 my neighbor, and allow AS in, right? Now what do you think? Will it ping? Now there is root in their routing table, so IP root 10 network, right? And there is root for 20 network, so IP root. But guys, will it ping? Will it ping? No, it will not ping. Now where traffic will drop, what will be the source? Source is 10.1, destination is 20.1, right? This traffic will hit on this interface, right? Now this router will check their routing table to forward traffic in 20 network, right? So go to R1, check routing table, so IP root. So yes, there is 20 prefix, right? 20. And what is the exit interface for this network? Via 3.3.3. So to forward this data to 3.3.3, what will be the exit interface? Serial 2/0. Now this router will or this traffic from this interface, right? When this router will install, this router will check destination IP. Destination IP is 20.1. This router will check their routing table. In their routing table there is no prefix for 20 network, right? So IP root. Is there any prefix for 20 network? No, right? Now this router will drop this traffic, right? So what we need to do over here is we need to redistribute BGP route in OSPF. BGP routes in OSPF over here and over here as well, right? But guys, remember, company is not recommending, you are not allowed to redistribute BGP route in OSPF. But let me show you, if I will redistribute, then will it ping? Let me show you. Exit router OSPF 100 and redistribute BGP, after that AS number 100 and subnets. Okay, now let me run the same command on R1. Configure router BGP, router OSPF 100 and redistribute BGP 100 subnets. Fine. Now guys, let me show you the routing table of R2 first. So now there is root for 20 network, yes. There is root for 10 network, yes, right? So now let me ping from here to here. Now it's pinging, right? Now it's pinging, but we are not allowed to configure redistribution, right? So let me remove the redistribution from here, right? Let me type no. Oh, router OSPF 100 and no redistribution. Now again R4 will not able to ping 20.1, yes, not able to ping. Now let me configure MPLS. Guys, I am going to configure MPLS. If you are thinking what is MPLS, how MPLS work, don't worry about that. You will understand when I will make video on MPLS, right? So what actually network engineer will do in real environment, in real scenario, network engineer will configure MPLS IP on this interface. Go to R1, configure terminal interface serial 2/0, MPLS IP on this interface, exit interface serial 2/1, MPLS IP on this interface, right? and in the same way you will need to configure MPLS over here as well. Interface serial 2/0 MPLS IP. Now this router will able to ping. Now this router can ping. Yes, it's pinging, right? So guys, this is how you will configure BGP in real environment, in real scenario, and hope you understand where we need to configure indirect ebgp, where you need to configure indirect ibgp. Okay, so in yesterday I had promised you that I will make video on where you need to configure indirect neighborship in BGP, so that's why I make this video, right? Guys, if you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. And if you want to know, if you want more video on BGP, right? If you want I should complete the BGP, I should complete the BGP series, please request me in comment to make more video. Okay, if you will not watch BGP series, then I will definitely stop making video on BGP. Okay, so that's all for today. Bye bye guys.